than 70% of the Earth's surface is covered by water. From the expansive oceans to small raindrops that fall softly on the ground, rivers that run deep, and the cool and refreshing groundwater. Water is the source of life for all of us. With such abundant water as its source, hydrogen energy continues to garner momentum as a new renewable energy. By the year 2050, it is expected that the global market for hydrogen energy will reach 2,500 trillion Korean won. One of the biggest benefits of hydrogen energy is that it is eco-friendly. The reason hydrogen is an eco-friendly energy is that it produces no carbon emissions. Hydrogen energy has recently gained the reputation of providing an eco-friendly mode of transportation. Then what is the most critical factor in the supply of hydrogen cars and the growth of the market? The answer? Market-oriented high-purity hydrogen production units. This is a core piece of initial infrastructure necessary for realizing a hydrogen economy. Let us have a look at this market-oriented high-purity hydrogen production unit developed by the research group led by Dr. Yoon-Hwan Lee at the Hydrogen Energy Research Division of the Korea Institute of Energy Research. The device is mainly composed of two modules, one for reforming and the other for purification, known as the VPSA module. These processes allow the production of high-purity hydrogen.
Let me introduce a general-purpose high-purity hydrogen production unit. It supplies hydrogen through the existing urban gas supply networks. You can bring hydrogen production facilities and hydrogen stations to the point of demand near residential or business districts in our cities safely and conveniently. Kier's design boasts three key advantages of high efficiency, high purity, and low cost of building facilities. The most important is high system efficiency. The two significant contributors to high efficiency are heat from the steam methane reformer and the design of mass transfer. Steam methane reformer, otherwise known as SMR, is a way of extracting hydrogen by heating methane with steam. It is a technology for extracting hydrogen through the reaction of water and natural gas at a high temperature of 700 degrees Celsius or higher. Heat and mass transfer in the process determines the system efficiency. This new SMR design was instrumental in achieving a high efficiency of 81%, which exceeds the 75 to 80% benchmark for early hydrogen energy production efficiency proposed by the Department of Energy of the US and the NEDO of Japan. This is a vacuum pressure swing absorption, also known as VPSA, system. It is an improvement upon the existing pressure swing absorption method. VPSA maximizes separation efficiency by employing a technology for optimizing the layers and arrays of 5 adsorbents that absorb and separate out such impurities as carbon monoxide, carbon dioxide, and unreactive methane. The method can reduce desorption pressure, dramatically increasing the purity of hydrogen and decreasing carbon monoxide concentration to 0.2 ppm and lower. The team achieved system efficiency of 80% or higher and hydrogen purity of at least 99.999% with the help of a combination of a new SMR design and VPSA technology for refining and absorbing technology. Installation and distribution of hydrogen production facilities and hydrogen stations are essential for widespread use of hydrogen fuel cars. Even only just one of today's standard facilities and stations costs a whopping $2,220,000 US. However, it just costs about 1/3 of that amount, $740,000 US, to build Kier's low-end, high-purity hydrogen production unit. Furthermore, it does not require additional investment in new infrastructure because it relies on the existing urban gas pipelines. With the use of Kier's technology, it is now possible to build facilities that produce and supply hydrogen energy near a residential or an industrial area in a city by streamlining the equipment and greatly reducing the scale of production and filling facilities. Hydrogen energy can fuel not only cars, but also the semiconductor, solar cell, metal processing, fine chemical, glass manufacturing, and pharmaceutical industries, thereby making a tremendous contribution to the building of an eco-friendly hydrogen city. It is hoped that the technology of this low-end, high-purity hydrogen production unit can facilitate the emergence of a green hydrogen society.
The Korea Institute of Energy Research plans to further improve the technology for its high-purity hydrogen production units, which we have learned about today, and adopt such technology in future projects for building small-scale decentralized production stations and hub production bases. We believe that the market-oriented high-purity hydrogen production unit technology will trigger further development of eco-friendly hydrogen as well as other renewable energy sources.